Hello friends, my name is Chetan Pardeshi. I have started this channel only for students. I would like to convey as much as possible for my students about science. Now I would like to talk about this topic called as gravitation today. Now whenever an object is thrown up, it comes down. That is because of the force of gravity. So we should understand what actually is gravity. Scientists are trying to find out what actually gravity is. But there is a name which comes to our mind, which is a name of a very famous scientist called as Newton. So Isaac Newton was an English scientist. He has done a lot of research in theoretical physics. He has done a lot of things in physics as well as mathematics. So there is a very famous story that tells us that once Newton was sitting under an apple tree, an apple fell down on his head, and he thought that why did this apple came down, why didn't it go up? And then by rigorous calculations, lots and lots of efforts, he gave us the concepts about gravity. Whatever he understood, we still use it for macroscopic objects. For big objects like the earth, sun, it still holds very, very close agreement with the experimental values. Now, first of all, we have to understand the universal law of gravitation. It says that every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now let me write down the equation. Suppose we have the force of gravity which directly proportional to the masses of objects m1 and m2 divided by the distance between them, square of the distance between them. Suppose there is an object of mass m1, another object of mass m2, and the distance between their centers is r. Then the force of gravity can be given by this way: F is equal to G m1 m2 upon r square, where G, capital G, is the gravitational constant. Its value is very, very less, about 6.67 into 10 raised to minus 11 Newton meter square kg square. Now this is a constant, capital G. It's a very small number. Now consider m1, m2. Suppose m1 is an object, for example you, and m2 is another object, for example the earth. Now you know that the mass of the earth is very, very, very large as compared to you or me. So if we put the values of masses in this, we see that m is a very large number and square of r, that is the radius of the earth, as we are on the surface of the earth. If we assume that you are on the surface of the earth, then r will be the distance between you and the earth. Square it, and then if you divide, you will get the force of gravity which acts on us. All objects that are there on the surface of the earth have equal acceleration due to gravity. Now let us take a simple example to understand what I am saying. Suppose you are on the terrace of your building and you throw your school bag and a pen. Which of them will touch to the ground first? Some of you might think that a school bag with a lot of books is heavy as compared to the pen. So it should reach first to the ground, it should touch the ground first. But that's not true. All objects on the surface of the earth, if you throw them up or you throw them down, will experience the same gravitational acceleration. That is also called as small g, gravitational acceleration. You might be knowing that acceleration is a change in velocity upon time. So its value is come to be 9.8 meter per second square. This is the value of small g. So you see that small g is same for all the objects on earth. Now there are people who are trying to do research and find out whether there is something called as gravitational wave. If you consider gravity and compare it with other forces like electrostatic forces plus between positive and negative charges, and nuclear force, which is much more stronger than any other force. Any object or small thing, electron or proton, when it comes near the nucleus, it is attracted by nuclear force. It is the strongest force in the whole universe. And after that, electrostatic force, that is between positive and negative charges. And after that, a very weak force which is called as gravitational force. Now why am I saying it is weak? Because as compared to the electrostatic and the nuclear force, it is very, very weak. But if you see the distance over which it acts, it is almost infinite. Very large distance. You just see that the sun is so far away from us, but it can have its influence on the earth. The galaxy center is a black hole which has influence over our sun. Different galaxies have influence over each other. What is the force that is behind it? It's just the gravitational force. It's a long range force, and it is a weak force as compared to other forces, strong forces. The nuclear force is the strongest of all of them. So gravitational forces, gravitational waves is a hot topic of research these days. People are trying to understand whether we could find gravitational waves. As we have the electromagnetic waves, if we could find out whether there are gravitational waves, then it will be great. People have already found some evidence about supporting this claim. Thank you very much.